In this video, we're going to learn how to write formulas for binary ionic compounds when we know their names. So there are two basic rules we're going to follow. We're going to first have to figure out from the name what the ions are that are in the compound. And then, because we know that compounds are neutral, we're going to have to use the charges on the ions to write a formula with a charge that is neutral, that is a total charge of 0. So let's use an example. We're going to start off with the name of a compound, which is lithium fluoride. And first thing we're going to do is we're going to figure out what ions are in the compound. Well, we know from the name that we have a lithium ion and a fluoride ion. But the question is, what are the charges of those ions? So to figure this out, we're going to have to go to the periodic table. So here's a periodic table. It doesn't have any names of elements, and we're going to put a couple in a minute. And we know that on the periodic table, there's a dividing line between the things that are metals and the things that are non-metals. So almost all of the non-metals are to the right of this line. There's one exception to that. We'll see that in a minute. And all of the compounds to the left and below this line that looks like a set of stairs are the metals. So the purple area here is the area where the elements that are metals are located on the periodic table. Let's locate our lithium element. Here it is right here in this square. Lithium has the atomic number 3. And since lithium is in group 1A, and we know that metals that are in group 1A, alkali metals, like to lose one of their electrons so that they end up with an electron configuration that's like a noble gas. When they lose an electron, they form ions with a +1 charge. And that's true of all of the alkali metals. So the alkali metals, now outlined in red here, form ions with a +1 charge. Okay? So now we can write a formula for our lithium ion, and it's Li with a +1 charge. So we can do the same kind of thing for the fluoride ion. Here in the areas shaded green on the periodic table are the nonmetals, mostly to the right of the staircase-shaped line. Hydrogen is the exception to that. Hydrogen is also a nonmetal. And if we locate fluorine, from which the fluorine ion is made, a fluoride ion is made, that is, we can find it here in this box on the periodic table. Fluorine is a halogen. It's in group 7A like all the other halogens. And we know that halogens have a tendency to gain one electron so that they can form ions with electron configurations that are like those of a noble gas. They have a certain amount of stability when they gain an electron. So we can show that here. We can show that the halogens outlined in this bright blue line form ions with a -1 charge. There it is, written at the top of this group on the periodic table. And we can now write a formula for the fluoride ion. Here it is right here under the name fluoride, F-. Compounds are neutral. That is, they have the same number of plus and minus charges. They have the same number of electrons and protons. So we want to combine these ions, the Li +1 ion and the F- ion, in a way that we end up with a compound that has no excess plus charges and no excess minus charges. It's pretty easy to see that in this case, if we combine one lithium ion with one fluoride ion, we'll get a compound that has a net charge of 0, +1 combined with -1 equals 0. And so our formula for lithium fluoride is LiF. What have we done? We started with the name lithium fluoride. We figured out what ions are in this compound. And we know it's an ionic compound because lithium's a metal and fluorine's a non-metal. And once we knew the ions, we can combine those ions to write a formula with a net charge of 0. And notice that the formula does not have any plus or minus charges signs in it. The formula doesn't have any plus or minus signs in it because the compound is neutral. There are no excess plus or minus signs. Let's try a little different example here. Here's another compound, nickel 2 chloride. Now we have something that we didn't have before. We have a Roman numeral next to the name of the metal cation. And the Roman numeral is there to tell us which nickel ion is being part of this formula. And the 2 indicates that the nickel ion in this formula has a +2 charge. So we don't have to look at the periodic table at all. We don't have to figure out where nickel is on the periodic table. We do need to know that it's a metal so that we understand that this is an ionic compound. But the Roman numeral 2 tells us that this is an ion with a charge of +2. So we can right away write down the formula for the nickel ion in this compound. Not all nickel ions have a +2 charge, and that's why the Roman numeral is there to tell us which type of nickel ion we're dealing with. Chloride, the chloride ion, forms from chlorine, and to find out the charge of that, we do have to go to the periodic table. Here are our nonmetals on the periodic table, shaded in green. Here's chlorine on the periodic table. Like the fluorine we looked at a minute ago, chlorine is a halogen. It has a tendency to gain 1 electron to form an ion with a -1 charge, like all the halogens do. So we can write the formula for the chloride ion, Cl-. And now, since we know both of our ions, we need to combine them in a way that we end up with the same number of plus charges and minus charges. Well, if every nickel ion has 2 plus charges, we're going to need 2 chloride ions, each of which has 1 minus charge, to get the same number of minus charges as plus charges. We can do that using our crisscross method, and we can figure out that we need 2 chloride ions for every 1 nickel 2 ion. And so the compound nickel 2 chloride has the formula NiCl2. We figured out what the ions were. We put them together in a way that gave us a neutral compound.